Hi there, on the bench today, two well-used DMMs in the same video. They are not mine, I got them to check their accuracy and, if necessary and possible, do a calibration. I tried to find some data on these multimeters, but this here is the best I could do. The Schneider IMT23000 was sold as part of a kit with a socket tester and a voltage test pen. It's a 2000 count meter and the basic specs are listed below here. Notably is the lack of any statement regarding accuracy. For the other meter I drew a complete blank. Hilka still lists a DMM on their website, but it's quite different from the one on the bench. So let's start with the Schneider IMT23000 high safety digital multimeter. It has a slider to select between functions and a rotary dial to select ranges and work as an on-off switch. A little round blob indicates the selected position, but it's not easy to see. Why did they not print a black arrow or at least make the blob a different color? If this was my meter, I would add that myself. Let's open it up. Two self-tappers hold it together. With those removed, the back separates easily enough. There's not all that much to see. A black beeper, a 20mm fuse, and a single trim pot. Not much in terms of protection either. The battery compartment is tiny and for a rather unusual battery type. Details of the fuse, a fast 250 mA type, and the needed battery are on the rear panel. The battery is a 12V type 23A or VA23A or MS21. To my surprise, these are actually not that expensive. For example, Amazon sells a no-name 5-pack for £3 plus delivery. Despite that, I'm not going to buy a new battery, but instead power the meter from my bench power supply using cork clips. It's a bit wobbly because the clips prevent it from lying down, but I think this will do. Current draw, by the way, is around 1 mA. That sounds low, but the 12V battery is tiny, so don't expect a fantastic battery life. I applied 1V DC for my data precision 8200 calibrator. What? 1.4 volts? This meter is way out. And with 0.5 volts applied, it shows 0.43? Oh, hang on, the function switch is in AC volts. Amazing that it reads DC voltage in AC mode. Switching to DC and it shows 0.496 volts, much better. Back to 1V DC and now it reads 0.994. With 2 volts it shows 1.989, so I think I should try recalibrating it. There is, after all, just one trim pot, similar to many old Fluke meters, and those are calibrated by simply applying a known DC voltage and changing the trim pot until the meter reads the correct voltage. That cal is then used for all other ranges. I assume this meter does the same. Instead of 2 volts, I pick 1.9 volts since the maximum display is 1.999. Changing the pot until the meter reads 1.900. There you go. Testing with 1 volt. Spot on. 0.5 volts. Okay, just one count out. 20V range now. Changing the input to 5 volts. And now 10 volts. 15 volts. And now 19 volts. All pretty reasonable. 200V range now, 20 volts, 50 volts, 100 volts, 250V range now. I think this looks pretty good. Let's try AC. I connect a 1V RMS sinusoidal source at 50 Hz from a function generator. The meter is in the 2V range. Well, that looks nowhere near 1 volt. It's 33% off. Let's try some other voltage. 3.14 in the 20V range. It's getting better, only 13% off. 24.3 volts in the 200V range, only 1.4% off. I connected both meters to my Variac and the Schneider is in the 250 volt range, which turns out to be the only working with a reasonable degree of accuracy, even for low voltages. As there is only one trim pot and we used it already for DC, there is nothing I can do for the lower AC ranges, but actually, as you can see, the 250 volt range is a fairly good catch-all substitute. Onwards to DC current, and nothing is shown on both meters, and since they are connected in series, for current this points to a blown fuse in the Schneider. Indeed, using the fluke to measure continuity, the fuse in the Schneider is blown. I replace it with a new fast 250 mA type as indicated on the rear panel. Testing a few DC currents in the one and only 200 mA range shows that the Schneider is pretty accurate, which doesn't surprise me as this is probably a direct result of the earlier calibration. Testing resistance now with my resistor standard consisting of 0.1% parts except for 100 meg, which is a 1% part. Starting with a 2K range, 1 ohm, okay, getting there, 10 ohm, spot on, same with 100 ohm, and with 1K, not bad. Moving to the 20K range, retesting 1K in the 20K range, and 10K. Moving to the 200K range, testing 10K in the 200K range, and 100K spot on. Now the last range of 2 meg, retesting 100K in the 2 meg range, and now 1 meg. It takes a long time, but it's getting there. Continuity mode, and the Schneider has a rather weak beep and some sort of pulsing that might be caused by the measurement cycles. It indicates continuity on 1 ohm and 10 ohm, but not 100 ohm. Probably it stops around 50 ohm or more, but I did not test that. Diode test works as you would expect, but the forward voltages are shown are very high compared to other meters, possibly because it uses a higher test current. 1.7 volts for 2 silicon diodes in series is crazy. Normally is 1 volt or less. I tested that and indeed it uses 0.8 milliamps where the Fluke 77 uses 0.4 and the Bryman 869S around 0.3 milliamps, but even with 0.8 milliamps the forward voltage is excessive. I connected the Bryman in parallel with the probes of the Schneider and measured a single diode. The Schneider shows 0.679, but the Bryman a more realistic 0.59. With 2 diodes in series, the difference is even more significant, with the Bryman showing 1.15 and the Schneider 1.73 volts. So the answer to the mystery is that the Schneider is grossly exaggerating the displayed forward voltage. Last not least for the Schneider, when does the low battery indicator come on and does it measure correctly until then? I'm using a 1K resistor and the meter displays the correct value until the low bat indicator shows at just 6.7 volts. Not bad, it means that 12 volt battery is used for all its capacity. That concludes the Schneider IMT23000. After calibration, the DC volts, milliamps and resistance ranges are fine. For AC volts, only the 250 volts AC range shows correct values and the forward voltages in diode test are too high. It is still a usable meter once you know about these issues. Are these in all IMT23000 or only in this one? If you have one, please let me know. Apart from this, I quite like the form factor and the way it stores the probe. Moving swiftly on to the Hilka 903-932, what a name. Pressing the on-off does nothing, so again the first step is to open the meter and find out why. Amazingly, just one screw secures the back shell of the Hilka. But to be fair, there are 2 clips at the bottom that help in keeping it attached. There's a 9 volt battery present, but it might be flat. Oh yes, there's nothing left. This can happen easily because the on-off button can be accidentally pushed and there is no automatic power off function. The PCB is just lying inside the meter and can be lifted out without much effort. This allows a peek on the component side. A complete lack of any SMD components reveals its age. There's even a standard DIL quad NAND gate and a dual op-amp at the bottom left. Not much in protection. The large 10 amp current shunt is impressive, and there's even a smaller one for the 2 amp range. There are 2 trim pots in this meter, marked not very helpful VR1 and VR2. To see if I need to worry which one is for what, I need to test the meter if it needs calibrating. For convenience, I use not a new but still reasonable fresh replacement battery. And while we're at it, a quick test of the 2 amp fuse reveals that it's still okay. With a replacement battery, the meter turns on. It has a relatively large display, easy to read. Apologies for the glare of the overhead lights. Let's test DC volts against my calibrator starting in the 200 mV range. 100 mV is fine, 50 mV also, 20 mV spot on, 10 mV spot on. Moving to the 2 volt range, 100 mV is okay, 500 mV is okay, 1 volt is okay, and 2 volt is just 2 counts out, that's 0.1%. Moving to 20 volt range, 2 volts is fine, 5 volts spot on, 10 volts is spot on, 20 volts is just 1 count out. 200 volt range now, 50 volts is fine, 100 volts is 2 counts out. 100 volts in the 1000 volt range is just 1 count out. DC volts is fine and does not need a new calibration. The difference are well within what's achievable by such a budget meter. For low AC volts, I use a function generator set to sine wave at about 1 kHz. The Hilka is in the 2 volt range and I'm feeding a 1 volt RMS, which is very close. Changing to 100 Hz makes no real difference. Out of curiosity, I changed to square wave, and if the Hilka is true RMS, it should show the same as the primary on the left. Instead, it shows 1.11 times more, which is exactly the behavior for the averaging meters calibrated to show RMS for sine waves. Back to sine wave, and both meters read the same. 100 mV in the 200 mV range is fine, and so is 10 mV. For higher AC volts, I use a mains powered variac. 10 volts in the 20 volt range, quite close, 100 volts in the 200 volt range, okay, and 200 volts. Switching to the 700 volt range, 282, and the Hilka is just 1.1% out. That is well within spec of similar meters, no problem with AC volts. DC milliamps starting with a 20 microamp range and feeding approximately 10 microamps in comparison with the Bryman 869S. It's very close. About 20 microamps and still close. Switching to the 200 microamp range, 50 microamps and the meter practically read the same. 100 microamps, all is fine. 200 microamps, still very close. 2 milliamps range now. 500 microamps and spot on, 1 milliamp and close, 2 milliamp, same story. Switching to the 20 milliamp range now on the Hilka and the milliamp range on the Bryman. 5 milliamp very close, same for 10 milliamps and 20 milliamps. Switching to 200 milliamp range, 50 milliamps is fine, same for 100 milliamps. For the higher currents, I use a DC power supply. Switching to the 2 amp range on the Hilka, 500 milliamps is spot on. Switching to the 10 amp range on the Bryman, 1 amp and the meters are close. Switching to the 10 amp range on the Hilka, 2 amps and the meter read practically identical. Same for 5 amps and 9 amps. I think the Hilka works very well in DC amps, no need for any calibration. Testing AC amps. For microamps and milliamps, I use again a function generator set to sine wave at about 50 Hz, feeding a 50 ohm load with the meters connected in series to measure the current, but I'm not bothering dialing in nice test values. Starting with about 19 microamps in the 20 microamp range, and both meters read very close. About 175 microamps in the 200 microamp range, and again very close. Same for about 560 microamps in the 2 milliamp range. Switching to the 20 milliamp range, about 2 milliamps and okay given the resolution, 4.5 milliamps and close. Changing the primer to milliamp and the Hilka to 200 milliamps, 32 milliamp and very close. Same for about 52 milliamps and 100 milliamp. For higher currents, I replace the function generator with my mains powered variac. About 0.5 amps and both meters are close. At about 1 amp and nearly identical. Switching to the 10 amp range, nearly 4 amps and both meters are close. Same for 5.5 amps. In summary, AC currents are fine too. Let's measure resistance the same way I did for the Schneider. 1 ohm and the Hilka says 1.2. For 10 ohm it says 10.2. That probably means the lead resistance is 0.2, which it is indeed. Since there is no rel mode, you have to mentally subtract that from the measurements. 100 ohms, okay. Switching to the 2K range, 100 ohms again. 1K, 0.3% high. Switching to the 20K range, 1K again, spot on. 10K, spot on as well. Switching to the 200K range, 10K again. 100K and the Hilka reads 0.3% low. Switching to the 2 meg range, 1 meg, spot on. And finally the 20 meg range, 10 meg, and it takes quite a long time, but finally it settles very close. Resistance modes are fine too. Let's quickly verify continuity, which is rather scratchy, and diode mode. Unlike the Schneider, the Hilka produces sensible values for the forward voltages where it can read them. Finally, let's look at the behavior when the battery voltage drops. The left meter shows the current draw and the right the battery voltage. In voltage modes it draws around 1 milliamp, but in continuity and resistance modes it draws more, about 1.7 milliamp in continuity, which isn't too bad for a 9 volt battery. Like many multimeters, the current shoots up when the beeper is active, but even so, in this vintage meter, the increase is still modest compared to many modern meters. I switch to the 2K resistance range and the current increases to about 3 milliamps. It now measures a 1K resistor, so I can see if the readings change while the simulated battery voltage drops. The low batch symbol appears rather early, just above 7 volts, which is a shame as this makes using rechargeable 9 volt batteries with a nominal voltage of 7.2 volts difficult. Okay, that's it. One meter that did not need recalibration and still works fairly accurately in all its modes and ranges, and the other that did benefit from a recal, but even after that has still issues in AC volts and diode modes. If you are on the lookout for a used meter, I would still say to avoid both, as you can get much better meters for very little money these days. If you have them already, no need to throw them away, just be aware what the limitations are and use them for electronics only, since neither of them is really safe for work in electrical installation. If you like my videos, don't forget to like and subscribe and help growing this channel. And consider becoming a Patreon. The link's in the description. Thanks for watching.